Hey guys, Mr. Martin with the review of the Taylor polynomials that we covered in class. So Taylor polynomials adhere to this formula where we have f of c plus f prime of c times x minus c plus the second derivative evaluated as c times x minus c squared divided by 2 factorial out to the nth derivative times x minus c to the n power over n factorial. C is the center of our Taylor polynomial. We will get started with the same examples we did in class and work back through this. So for example 1, we have f of 2 is 3, f prime of 2 is -4, f double prime of 2 is equal to 7, and the third derivative evaluated at 2 is -5. So according to this formula for our Taylor polynomial, we're going to have f of 2 plus f prime of 2 times x minus 2 to the first over 1 plus the second derivative evaluated at 2 times x minus 2 squared over 2 factorial plus the third derivative evaluated at 2 divided by 3, times x minus 2 to the third power divided by 3 factorial. Oh, I forgot to write P3 of x equals this. So this third degree Taylor polynomial adheres to this formula. So if we simplify this, we're going to have P3 of x equals f of 2 is 3, f prime of 2 is -4. So we're going to have -4 over 2 factorial, which is, we're going to have f prime of 2, which is -4 over 1. So -4 times x minus 2. And 1 factorial is also 1. So then plus f double prime of 2 is 7. And 2 factorial is 2. So we'll have 7 halves times x minus 2 squared plus the third derivative evaluated at 2, I guess we don't need the plus, is -5. And 3 factorial is 6. So -5/6 times x minus 2 to the third power. So this step is not necessary, but it does match the form of what we're doing right here. So our final answer is 3 minus 4 times x minus 2 plus 7 halves times x minus 2 squared minus 5/6 times x minus 2 cubed. For example 2, we have to write a 4th degree Taylor polynomial for f of x equals e to the 2x evaluated at x equals 1. So following the same formula, we're going to have P4 of x equals, all right, so we're centering this at x equals 1. So we're going to have f of 1 plus the first derivative times 1 times x minus 1 plus the second derivative evaluated at 1 times x minus 1 squared, and all of that is going to be over 2 factorial, then plus the third derivative evaluated at 1 times x minus 1 cubed over 3 factorial, and then finally plus f of 4, the fourth derivative evaluated at 1 times, let me extend this out, times x minus 1 to the 4th over 4 factorial. So when we write, let me zoom out just a bit. So to fill out all of these terms, we need to do a couple of things. We first need to get all of our derivatives. So the first derivative is 2e to the 2x. The second derivative is 4e to the 2x. The third derivative is 8e to the 2x. And our fourth derivative is 16e to the 2x. If we substitute in 1 for each of these, we would get 2e squared, 4e squared, 8e squared, and 16e squared. And also f of 1, if we fill this in, is equal to just e squared. So every constant in this expansion has an e squared involved. So what we're going to do is factor out that e squared so that we get p4 of x equal, so we factor out our e squared. That means that instead of the first term being e squared, we divided it by e squared and we get 1 plus, then all of these other terms we've taken e squared from, so we're going to have just plus 2 times x minus 1 plus the second derivative is going to be just 4 instead of 4e squared. So 4 times x minus 2 squared over 2 factorial plus, then the third derivative is going to be 8 times x minus 3 cubed over 3 factorial, and finally plus 16 times x minus, all of these should be centered at 1. So x minus 1 to the 4th over 4 factorial. So this should be a 1 and this 2 should be a 1. I just went up because of the exponents. That is entirely incorrect. All of these are centered at x equals 1, which means x minus 1 should be each one of these factors. So this should be x minus 1, this should be x minus 1 squared, this should be x minus 1 cubed, and this should be x minus 1 to the 4th. My apologies. So when we simplify further, let's create some room. We're going to get e squared times 1 plus 2 times x minus 1 plus 4 divided by 2 is just 2 times x minus 1 squared plus 3 factorial is 6. 8 over 6 is 4/3 x minus 1 cubed plus 16 over 24 reduces to be 2/3 x minus 1 to the 4th power as our final answer. For example, okay, so we did example 3 in class. We're going to skip this example and move to example 5. So we're not going to do example 4 because it does not actually pertain to the Taylor series. In class, we said that this was a trick question to get you to know things about a polynomial, quadratic, instead of just doing a Taylor expansion. So number 5 is the next example where we actually use a Taylor expansion. So we know that P3 of x is equal to 1 minus 5 times x minus 4 squared plus 8 times x minus 4 cubed. It seems as if our Taylor expansion is centered at x equals 4. So let's write the general form for this. We're going to have f of 4 plus f prime of 4 times x minus 4 to the 1st power plus the second derivative evaluated at 4 times x minus 4 squared over 2 factorial. Then we're going to have the third derivative evaluated at 4 times x minus 4 cubed, and that's going to be over 3 factorial. So all we have is the coefficients of these terms. So it should be pretty obvious that f of 4 has to be 1. So the first thing is we know f of 4 immediately equals 1. The second thing is we have the first term, we don't have an x minus 4 to the 1st power. That's going to tell us that f prime of 4 is equal to 0. So 4 is a critical value. Let's keep that in mind. If the derivative equals 0 at a particular point, that's a critical value. The second derivative evaluated at 4, that's what we're looking for. So the relationship we have is the second derivative evaluated at 4 divided by 2 factorial is supposed to equal this coefficient. So this is going to tell us that -5 equals the second derivative evaluated at 4 over 2 factorial. So 2 factorial is 2, so 2 times -5 is going to mean that -10 equals the second derivative evaluated at 4. Likewise, the coefficient for the third degree term is 8, and that should equal the third derivative evaluated at 4 divided by 3 factorial. So we're going to get, if you allow me to slide this over, we're going to get 8 equals the third derivative evaluated at 4 over 3 factorial. So we multiply, so 3 factorial is, in parentheses, we're going to put 6 and cross this out. So 6 times 8 is going to mean that 48 is equal to F3 of 4. So this value was 1, this value was 0, this value was -10, and this value was 48. And so for part B, does F have a relative maximum, relative minimum, or neither at x equals 4? The reason this is of relevance is that we know 4 is a critical value because the derivative equals 0 at that point. So we can use the second derivative test to classify f of 4 without having to do a sign chart. So we did the second derivative test a while ago, and it is this. If f double prime of 4 is greater than 0, f of 4 is a relative minimum. If f double prime of 4 is less than 0, f of 4 is a relative max. And if f double prime of 4 equals 0, inconclusive. So we know the second derivative for 4 is -10. So f double prime of 4 is equal to -10, which is less than 0. So it means that f of 4 is a relative max. So we're going to say f has a maximum at x equals, and we'll extend this out, at x equals 4. All right, so guys, that concludes this video over Taylor series. In the next video, we're going to work through example 6 in the next page of your notes. Thanks.